So first of all, thank you very much for attending. You're on mute. You won't be able to unmute yourself. I will unmute you at the end, or give you that ability at the end of the session, so that you can ask questions. But of course, please put questions in the chat. Butch and sorry, I've got a dry throat. Butch and Chris will be keeping an eye on the chat. If the question needs a response at that time, then they'll make that response, and or leave until the end, depending how the session is flowing. So this is session 3AR. It's Are You Truly Optimizing Resiliency on IBM Z or Z, depending on which side of the pond you reside. And the session is given by Butch Rambish and Chris Taylor from 21st Century Software. Yep, so as I said, session 3AR, please remember that for your feedback forms. We really do use the feedback forms, and we are already planning next year, and we are reviewing all the feedback. In fact, there's conference feedback as well, so at some time, if you can remember to fill that one in. This year as well, we are supporting two charities, as we always do, Lifeboats and Guide Dogs for the Blind. Please give very generously. This is really your raffle ticket entry as well. So for every £1 you donate, you will be able to get a raffle ticket. As you know, for those of you that have managed to join us on face-to-face type conferences, we always go around with a bucket, and we always collect a lot of you from you generous people. So don't let us down. All right. So at this point, I will hand over to Butch and Chris, and I'll be back at the end to talk to them. Okay, over to you.
Thank you, Anna. Before we get into this particular presentation, want to make you aware there is a related presentation that Chris will be doing next Thursday at the same time slot. And he will be talking about visibility and surgical recovery for cyber resiliency, specifically talking about cyber vault and how to get be efficient and automated in terms of getting data out of there. So put that plug in there. So let's kind of get into it. One of the things that is is true of the IBM Z environment is it has changed dramatically. I started in the mid 70s, and in some respects I can look at the mainframe and I can say, oh, there's a lot that's the same. But within the context of the business and how organizations use the Z platform, there have been quite dramatic changes, and I'm sure I'm not telling you something you don't already know. But one of the things about batch is there's this conception that batch is kind of old school. Batch is, for some reason, people think of it as lower important work. And maybe there's some truth to that in the sense of urgency, because onlines tend to get the bulk of the priority and everything else. But let's face it, if the work was not important, your business wouldn't run it. You run the batch work because it's the right platform for that kind of work. It's exactly what it says it is, right? It's large batches of work that have to be done. And so when you look at resiliency of the platform, you're only as resilient as your weakest link. When we talk about resiliency, we're simply talking about meeting your business objectives for keeping things available when you deliver work to your clients, whether they be external customers or internal customers, but you have some service level agreement, whether it's formal or informal, and regardless of what's going on in the Z ecosystem, you still need to be able to meet those agreements. Now, when we think of resiliency on the Z platform, there's a lot of things that come to mind. And one of the things about the Z platform, it's still the most resilient, the most reliable system out there. I don't think anybody could argue with that. There have been hardware and services offerings, for years that have helped us to achieve, the order of magnitude of 7 nines availability. But most of those solutions are really dependent on things like the database managers to take care of the applications. They're mirroring data, they're replicating data. There's really no knowledge within those technologies about the specific applications. They let the software manage that. The piece that's really missing is your batch resiliency. How do you recover your batch? And we're going to talk more about that as we go through. But the non-database managed data that doesn't have a forward recovery, a log, those kind of things, how do you keep the same level of resiliency? And if your batch is not resilient, how resilient is your overall environment? If you can't get it in sync with all of the databases, a lot of database updates come from batch. They start out as files that maybe were come through an open system from the cloud into your data center, and you're going to be able to process that data. It ultimately ends up in the database. Well, if you recover your database to a certain point, how do you make sure that you can process and get caught up with the batch side of it? And so that's kind of what we'll be talking about. I kind of already talked about this. Non-database managed data simply is data that's not managed by things like DB2 and IMS. Your databases have significant technology for recovery. I can recover a DB2 file. It doesn't matter if it was open at the time of the backup. DB2's recovery capabilities can handle that. They can deal with it. That's not the same with batch data. Whether the data set was open at the time of a backup or not is important. And that has to do largely with things that are mirroring or safeguarded copies, those kind of things. But we need to know the state of the data, and we need to know it where it is in terms of context of the application cycle. Where's the application life cycle? How many jobs have run? Which jobs ran? Which data sets have been updated? So when we look at recovery, resiliency for batch, if I have a failure, some sort of interruption, and I have to recover, I've got to find out what data sets and what are the application dependencies. Very often we find data sets that are used by more than one application. Do I know that? How can I identify that? I have to call the application teams. Do I know which application teams to call? How far back do I need to go for the recovery? What kind of forensics do I have? Can I look back and see what's been updated? What led up to the corruption in terms of work, and how can I identify that? Then I've got to go through the manual processes of creating JGL to delete and redefine data sets. I've got to find the backup. How was it backed up? Was it backed up with DFDSS? Was it backed up with CA disk? Was it backed up with IEB Jenner or ID cams or whatever it might have been, whatever the utility might be? I've got to know what the backup is. I've got to create JSL to restore it. And then once I get it restored, then I got to figure out what jobs I need to rerun. And so all of that takes time. And the difference between a disaster and an incident is merely a matter of time. The smallest error, if it drags on for a significant period of time, can become quite costly to an organization. And so recovery being manual, it can take hours or days. And we've had some customers that we worked with that simply lost a ParmLive data set for one of their applications. And it took them like 3 or 4 hours just to get one data set recovered, because they weren't really tracking the backups. They didn't know where it was. And so, it can become costly and difficult. So what we're going to talk about is a solution that really is designed to automate it, to be able to use real-time analytics to understand what's going on in the batch environment, how sequential and VSAM, those types of data sets are being used, which ones are critical. Are they being backed up? Are they being backed up too much? Where are those backups? Being able to track it, understand the life cycle of an application relative to the batch processing, so that all of this process can be automated. It starts with analytics. If you're going to have batch resiliency, there's a lot of information you need to be able to look at. We look at a lot of SMF data for this purpose, to be able to help organizations and companies to keep their batch resilient, as resilient as their databases. So we use SMF data. For Unix file systems, we also look at some SMF data for that. We track all the DFDSS backups, as well as backups from any utility, whether it's another product like CA Disk, or whether it's homegrown utilities. Whatever the type of backup, we can track that. We also look at safeguarded copies for that type of replication or copy or backup, if you will, as well as ABARs and HSM and tape management catalog. All of this information comes in and is used to create an inventory of the critical data sets and track all of the backups. It's kind of a high level architecture of the solution. It starts with an application table. The application table is from the job scheduler. The job scheduler is really the key piece of information for tracking the batch, which makes sense. That's what people use for managing their batch data. We use the job scheduler to identify which applications the job belongs to. And then we begin to track that, all of the jobs and all of the data set accesses by application, so we can understand when applications open them for read, when they open them for write. We also track the backups. We have reports for audit. Did somebody update or read a data set outside of the scheduler? That would be important to an auditor. If it's outside of the scheduler, it may be a source of corruption. It may be a source of an attack. Data dependencies. Is a data set used by more than one application, which is critical to know. If I restore a data set, I need to know not only to recover this application, but I may have another application to recover. The timeliner really is a facility for looking at the history of jobs, sequence of jobs, looking at from a point in time, look backwards. What were the jobs and the other data sets that led up to an update? What data sets were updated? Which ones were read? And kind of look back in a reverse cascade type feature. And then forward cascade would be looking forward. So if I restore a data set and I need to know, well, what jobs are dependent on that data, I can then see very quickly which jobs have to be rerun. As far as automation, a lot of organizations, have limited skill sets. People are leaving, and it's hard to get everybody trained. And you end up with a lot of different JCL and non-standard JCL. And the idea is to be able to make it standard, make it easy for somebody to submit a restore, or to be able to find the restores, submit them, and then make sure that the parameters are consistent all the time. And we use templates for that. The templates can be customized for any local standards, as well as the utilities that are used in-house. The one on the screen is a DFDSS example, but if somebody used CA Disk, we have templates for that as well. And the idea is to create standard, consistent, and reliable JCL, so people aren't scrambling at a critical time when you need to get something restored quickly. They're trying to figure out, well, which parameters do I need to use? How do I get this restored? And when the system is doing the restore, if you use multiple types of backups, it'll know for a particular backup, and it'll use the right template for generating the JCL. I mentioned the app table is key. Again, we get that information from the job scheduler. Today, for IBM's job scheduler, we have a dynamic interface, but all of the schedulers, including the IBM Z workload scheduler, start off with a batch interface that's typically run once a day, gathers information in terms of what's in the schedule, what applications, own each job, and it's the key for processing and analyzing the data. The other thing is we process the data in real time. This isn't a batch process where we just take a 24-hour period of data, once a day and run this long running batch job. We're getting the data directly from the SMF buffer. We have a number of subtasks underneath this address space. So for efficiency purpose, we can accomplish a lot of things very quickly. And we create an inventory of all of the critical data sets. We have a database of all the backups. We track the ZFS file systems. We also have a feature called the 3D virtual catalog, which Chris will demonstrate more next Thursday. But the 3D virtual catalog is really what we use for our Cyber Vault surgical recovery, because data sets can move from volume to volume. The 3D virtual catalog is really a way for us to track over the life of a data set which volumes it's on. So if I need to go find where it is in backups past, I know which volume it was on at that time. And again, kind of an advertisement for next Thursday. You'll get a lot more information on that then. And then we also have some SVC and exits that we use for looking at the real-time view of what's happening in the system from a batch workload. So we can look back at the last 24 hours or sometimes longer, but that's the forward cascade and the reverse cascade reports. And we get that information by looking at opens and closes. The backups, this is an important thing for us, is to be able to track all the backups. So for every data set that's backed up, we will know which backups it exists on, what the utility was that backed it up, so that we obviously know how to restore it. And we also track even full volume backups. So if you're doing full volume backups, we cut a type 202 SMF record, and we know which data sets are on there. So we can actually know that if you back up, a particular volume and it's got this list of data sets, that'll be tracked within the system. So we can do data set recoveries from the full volume backup. We keep a lot of information on the data that on the data sets or the files that we're tracking. And of course, this information is important, so we know how to delete and restore or redefine if we have to. We just have all the information necessary for keeping those files resilient. We have used this to help and aid encryption. That's not what we're here to talk about today, but there is a lot of information that helps. Chris will demonstrate some of the reporting features, some of the reports, but there are a lot of reports that come with the product that are really helpful. I mentioned the audit report shows jobs not listed in the application table. We have a lot of reports about the backups. Very often when a customer goes down this path of batch resiliency, one of the things that they do if they don't have a tool for monitoring their backups is a lot of times, when in doubt, back up. And so what happens is we find customers are backing up data sets many more times than necessary. Chris will demonstrate that, but we can identify when you're backing up too often. You're wasting resources, you can save a lot of time. We can identify critical data sets that aren't being backed up, which is obviously important. If you want to be resilient, you need to make sure you have your data backed up. And there's a lot of others. The cross dependency report is going to show files that are used across multiple applications. Quite often, the first time a customer runs that report, the response is, why is that application accessing that data set? And maybe somebody copied some JCL and left a DD statement in and they just didn't know it. More likely than not, the data set is actually used and they just weren't aware of it. It's news to many customers. You can also offload the data in a CSV file if you want to do some ad hoc reporting. Now, one of the things that we see a lot is customers have a really time-constrained batch window. And it's really critical for this to finish in time for the onlines and just to make sure that all of the processing's done before the critical part of the online environment starts or whatever it might be. And typically what happens is all of the batch jobs and applications run throughout the night, and when they're done, then they kick off the backups, and all the backups run, and then the batch window's completed. We have a dynamic scheduling capability. Since we know the pattern of usage and we know when data sets are eligible for being backed up, but we can actually kick off backups throughout the night, and we will mark files that are ready for backup so they can be backed up earlier. And so it helps to reduce the batch window, the pressure on the batch window, by allowing backups to happen throughout the night. Often the tape critical data sets are kind of ignored from the standpoint of resiliency. So from a virtual tape support standpoint, we can ensure that those critical data sets are also backed up, and to help your batch to have the level of resiliency that you require. Provide a capability for simulating your recovery. If you need to prove to your auditors that that you can meet the resiliency standards that are necessary, it's helpful to be able to test that out and make sure make sure that you can do and recover the applications in a timely manner. We recently added support for the Unix file system, and by tracking at the mount point, we don't get down to the files or folders within the mount point, but we can recover a mount point. So if you needed to recover a file, you could recover it to a new mount point name and go get the data out of there. But it's becoming more and more critical for from some companies to be able to back up and recover your Unix file systems as well. So ultimately, what the purpose of the solution is to be able to present to you any of your critical data sets, and as simple as putting an R next to the data set that you need to restore, press enter, and it'll give you some very easy to fill in parameters that are common, things like what's the new name I want to restore it to. Often, you might want to restore it to a new name to verify that the data is as you would want it to be, and then you can rename it to put it in production. And some other parameters, and press enter, and you get the JCL for the particular, in this case, it's a DFDSS restore. The right parameters that points to where the backup is. It has all of that information, so you don't have to type that in or go find JCL to run. Timeliner, I mentioned this earlier. The idea with Timeliner is, if you have a corruption that happens at, let's say 1 in the morning, and this is data set I'm going to restore, I'm going to restore it at 1 o'clock. What work is dependent on that data set going forward? Now, a lot of people will say, well, we'll just restore to the scheduler. And there's nothing wrong with that per se. I mean, the scheduler knows all the work, but the scheduler is going to run everything based on job dependencies. We look at it from the perspective of the data set and what happens from that data set going forward. So we can show you for each application, not just one application, but if another application is dependent on that data, it will also show up. But you can selectively then just run only those jobs that are dependent on that data. If I restore that data set, I don't need to run jobs that had nothing to do with that data. So I can be more efficient and get recovered quicker. At this point, I'm going to turn it over to Chris, and Chris is going, oh, I'm sorry. No, not yet. Hang on, real quick. Cyber Vault. Chris is going to talk more about this with the surgical recovery, but Cyber Vault is one of the newer areas of resiliency that customers are spending a lot of money and time. And it's really with regard to things like ransomware, and these are things that have been in the news lately. Everybody's heard about, here in the States, we had the Colonial Pipeline, which down here in the Southeast, it really shut us down with, we couldn't get gas for our cars for a couple of days because of it. And there's quite a few other incidents. One of the things that has made this so different, we tend to think of hackers as being this, young teenager or college kid. or college dropout, in a dark room. He's kind of trying to hack into something. It has changed dramatically, and it is now as well funded as a lot of the companies we work for. It's ransomware as a service. You have large companies that are paying individuals to actually do the attacks for them. And because of this funding, there's a lot of things that are happening and are going to happen, and we need to be prepared for them. So there's a lower barrier to entry. The financial impact is great for companies, and so Cyber Vault and cybersecurity has really taken the forefront. Here's another example. This is from a European company, but it was an attack that came in from the cloud, from another platform. But that's the key. The thing is, we tend to think of the Z platform as being impervious, and I think it's a little bit dangerous for us to think of it as being impervious, because there's going to be data that could come in from an FTP, from a business source, or somewhere in the cloud. The Z platform is just another platform in the hybrid cloud environment, and so we need to be vigilant for data that could corrupt our applications, and it could come in from another part of the cloud. So safeguarded copy is one of the things that is part of the IBM Z Cyber Vault solution. And when you set up a safeguarded copy, there are going to be hundreds, if not thousands, of these copies. And it's like, if I want to find a picture that I took of a big fish on a fishing expedition last summer, and I want to show it to you, and I had all of my pictures in one directory, I'd have to scan through there looking for that one particular picture. And it's like that with the safeguarded copies. Your data set lives out there in one of those copies, and you need to be able to find the right one and restore it in a timely manner. So a couple things that we do. One is for safeguarded copy, we have a health check report. The health check report for all of your all of the files on a safeguarded copy. If it's a sequential file or a VSAM file, we'll show you the state of the file at the time of the safeguarded copy. Why is that important? Well, it's important because you're not going to be able to start your processing up on a data set that was open for output at the time of the safeguarded copy. That would be a fuzzy backup and probably not valid. So with the Cyber Vault health check report, you can identify another safeguarded copy where that file was closed, or possibly an application backup if that were appropriate. A lot of it depends on the circumstances of the corruption and why you're restoring. There's a lot of value for the solution in a Cyber Vault. We can help out with some of the data validation, as well as a lot of forensics analysis for looking at where data sets could have potentially been corrupted. We don't know, we can't look inside the data set and know that it was corrupted, but we can show you the history, every job that updated it, what was that led up to the update, so that you could identify potential points of corruption and begin to investigate jobs and users. Surgical recovery, be able to go out and get a single file if you need to from a safeguarded copy in a very timely and automated manner. That's what Chris will be demonstrating next Thursday. So there's a lot with Cyber Vault that we can help with. The vast majority of the instances using the Cyber Vault is not going to be a catastrophic recovery. You're not always going to go restore everything in your environment. Many times you're going to want some kind of surgical recovery and recover a particular application. You're going to need to be able to do that in a timely manner to help get your system back up and running. The Cyber Vault is designed to be the place of last resort. It is not designed to replace your application backups. So a lot like your application backups, though, you want to be efficient and you want to be able to get the data back as quickly as possible. For your safeguarded copy for surgical recovery, we basically present the data back to you. This is where the 3D virtual catalog comes in. If you think about it in a systems managed storage environment, when a data set gets recreated at some point in its life, it could move from one volume to another. If I needed to go back in time and restore from a previous safeguarded copy, how do I know what volume it was on that particular safeguarded copy? Remember, safeguarded copies operate at a volume level. So if I go back, 12 hours and I'm looking to restore a data set and I'm doing it in a manual fashion, what if the data set had moved? I'm all of a sudden now I'm looking on all the different volumes to try to find that data set. The 3D virtual catalog tells me immediately what volume it's on for each safeguarded copy. It understands the life cycle of that data set and where it is. Just like the other restore, you press the type of R next to the data set you want to restore, and it'll generate the JCL to do a surgical recovery from the cyber vault, from your safeguarded copies to get the data back. Okay, now I'm ready to let Chris do the demo. Chris?
Okay, thanks, Butch. I'm going to hopefully take control here.
You want to, okay, you got it.
Got it?
Yep.
Okie dokie. So I'm going to take the next few minutes to go through some of the things that Butch was talking about and show you a quick demo of some of the features that are available in IZBR. Butch and myself, by the way, just to kind of introduce ourselves, we are technical sales executives with 21st Century, working very, very closely with IBM to help assist customers with solutions such as IZBR and other solutions that 21st Century develops. And part of this is also we've been working very, very closely recently regarding the whole resiliency and especially with the Cyber Vault solution, which, as Butch mentioned, I'll talk about more next week. Going back to batch resiliency as we know it today, the core of what we have in IZBR comes, as Butch said, from the job scheduler. So here, what we have in our demo environment, which is based in Australia, we have some test applications that are set up. So let's say, for example, this would be the output that is created once a day from the scheduling system, and we then feed it in and we can monitor the jobs and know exactly what we consider to be the critical jobs as part of the applications, so that you're not just monitoring regular jobs or other jobs that might be part of infrastructure, should we say, rather than applications. So I've got a few jobs defined here, which includes things like test applications, as well as some FTP tests that are going on. And this is fed into an application table, which is then within IZBR, which is then basically updated all the time from the various environments and LPARs which are running in this Sysplex. So that was one of the features when we talk here about the dynamic app table. That was one of the features that came about in in release 2, which was released in June of this year. And what we also were then able to do is we were also able to integrate a little bit more with IZWS. So and bear with me on this. I'm not a scheduling expert, so this is how I do it, and hopefully it's the correct way to do it. But what I'm going to do is I'm going to one of the features that we did with the dynamic app table is using the exit 7 in IZWS was to be able to add ad hoc queries that would instantly then be monitored by the system. So not just the things that get run once a day, but anything that gets added to the scheduling system throughout the day. So what I would do here is I would do the create, and I already have an application defined called ad hoc, and I would then fill all this information in to have this job run when I want it to run. In my case, I'm going to try and get it to run immediately. I'm then going to change this to a job that I have defined in the system. So I'm going to call it ad hoc 1 in this case, or Q ad hoc 1. I'm going to submit it. It will get executed, completes. And then from within IZBR, what I can actually do is, because it's now been added to the app table, if I go back into the app table, if things go according to plan, we will now see an Apple ID called ad hoc, which was not there before. And we can see here that Q ad hoc 1 is now being monitored by IZBR Now, if that's something that needs to be permanent in the app table, by definition, I think an ad hoc job wouldn't be, but that would be something then you'd have to, add into your regular plan to run. But what we can also do then from within IZBR is if we go into the timeliner application or function within IZBR, we can even then drill down and we can see, for example, that this job is already automatically being monitored. This is in Perth, Western Australia, so it's 1:33 in the morning there. So this would be the job that I just ran. So immediately available and immediately available for further analytics within the product. The app table that we derive from the scheduling system will then be fed into the IZBR inventory. And that's the core of the analytics that we have within IZBR. So I'm going to look at one of my applications here and elaborate a little bit on what Butch was talking about when we talk about critical data sets and the like. So I can sort here by status within IZBR. So for us, a critical data set is a status of 1 actually and 2. So what we call an exception, but both 1 and 2 are considered critical. What does that actually mean? A critical data set with a status of 1 is a data set that is used for input only. The difference between a 1 and a 2 is that a status of 2 is a data set that is open both for input and output. So in my case, I only have 1 that's got a status of 2, and that's a reports data set which gets updated by the application cycle. Now, why is this important from a resiliency perspective? Is often these are the forgotten children. These are the ones that people forget about. They remember the 3s and the 3s to a lesser extent because those are data sets that get deleted, but the 4s are the data sets that get created, let's say, on a daily basis. So you can see here, for example, there's something that looks suspiciously like a GDG. So those are data sets that get added to every day and could be recreated at will. But it's often the data sets that are only used for input or input and output that get forgotten when it comes to a disaster or to some form of resiliency. The other things that are tracked in the inventory, for example, is we have creating job names, we have first access job names, those kind of things as part of this application cycle that goes on. We also see different file types. So if you see a blank here, that means it's a sequential file. If you see C, that means it's a vSAM cluster. P means a PDS or a PDSE. And then we also have the GDGs in this case as well. So there will be data sets that are associated with that. Other information in the inventory is that we also store the size from it so that we can see from a recovery perspective how big this is going to be. Typically, a lot of the data sets that you'll see here will all be all the same size, but some of them, for example, we'll see what is the current allocation versus what is the highest allocation that this data set has had. So those are also things that are tracked with the inventory control. And this is information that is updated in near real time. This is what is reading the various SMF records, the 14s, the 15s, 30s, and then the 60 type data SMF records for vSAM clusters. That's what's being pulled in at that particular point as well. Now, from this inventory data set, we can divide database, we can derive some of our reporting here. So one of them we're going to look at from the inventory is something called the cross-dependency report. And in here, this can be quite convoluted depending on what you have going, but we can see here, for example, any application data set that is being referenced by different applications. So we have that testing.reports that we saw earlier on. That's being referenced by all applications because basically every job is updating that reporting data set. But here, for example, we can see that this particular job was probably originally created by an FTP job. So that's how it came into the system and then was further referenced by the actual base application, which in this case was INSCT. It's one of the most common things we see when we go into a customer environment for the first time. We hear the question, why is that application using this data set? And so that's using the analytics that we have in IZBR. We can then drill down further and fully understand how it's being used as well. Continuing on here, we Part of the resiliency feature is, of course, to make sure that you have backups and that you have enough backups and not too many backups. It's kind of like always the two-edged sword, making sure that you have enough sufficient backups, but not too many. So what I'm going to do is I'm going to look at a different application here and look at the kind of information that we have stored in the backup table, as well as go through a recovery process for you. As Butch mentioned in his part of the presentation, we monitor a lot of different kinds of backup methods, not just the IBM ones such as DSS or IBGena, or we also have an IDCAMS example, I think, in here somewhere. What we also monitor is other vendor products such as CA Disk or Favor, and we can even monitor homegrown products, assuming that they generate the correct SMF records that we need to read that. Now, in the backup table itself, we also monitor the output location of a backup. So say, for example, here you can see on the right-hand side, this is the name of the output data set. As in this particular case, it was going to a disk device, and we can see which volume serial it went to. If this was actually going to tape, we don't have tape active in this environment, but if this was going to tape, that would be somewhere where we could use, so we can plug into the JCL and say, okay, do the recovery from this tape volume, even if that tape volume were not to be cataloged. One of the other things that gets tracked in the inventory is, let's say I have a backup from the 3rd of November, which was yesterday. I can see here, oh, this particular job updated that data set since the last backup. But I do have a later backup that hasn't been updated, so that might be the one that I might want to use in this case for the recovery. So how do I go about a recovery? What I would do here, for example, is I would take this DSS copy and I would type R next to it. From here, I'm then presented with a panel for which basically is what I'm going to plug in some information into. I'm going to say, okay, I'm going to call this data set Chris T.test1. In here, I'm also going to say I'm going to replace any existing JCL that I have in this library. I'm also going to replace the data set. That would be this output data set if it exists. And generating the JCL, then I would be presented with DSS statements. So I've been using DFSMS DSS probably for the best part of about 30 years. So they're not always the easiest statements to understand. So what I would do in this case, this is all prepared for me so that I can then submit the job. Now, this is using, as Butch described, this is using IZBR templates that we have in the system. This is the restore template for DSS. And if there's something about this that I don't want my general user population to see, then I might remove some of these. I could still add them later on if I wanted to, but say, for example, I say, well, you know what? I don't want to restore to the active sphere in the GDS. So I can make the change here temporarily for this one job. But if I wanted to change that on a global level, then I would, I could remove that from the template so that wouldn't appear. We're working with customers at the moment to implement so that they can track their DSS backups. So their logical backups that are going to be used by the applications will now be able to be tracked by IZBR so that we can provide a common look and feel for the recovery process that they can use. Now, in the case of a Jena, which would be an IB Jena, the front end would look exactly the same. I'd say here, okay, I'm going to restore the data set, but this time I'm going to call it, I'm going to restore it to REST2. Now it's generating, because we don't have the data set attributes like we do with ADR DSSU or DSS, we're actually allocating the data set up front, and then they're going to run the Jena job to actually feed the information into Jena. And again, here, this is something that is customizable in the template to say, I don't want to supply the SMS attributes in the job. I want to let the ACS routines take care of that. And then we could change the template to do that as well. Now, the information you're seeing here, this allocate information, is actually coming from these allocate backup methods here, which is not really a backup method. It is more actually just the attributes of the data set that get stored alongside the jobs. So in addition to being able to effectively do recovery of data sets, we also have reporting capabilities for backups. So within our reports, we run something called the backup report, and this is actually a complete index of all the backups that are stored. Now, by default, the backup method would be the critical data sets, but you can also change it to, to incorporate modified data sets. Now, for demo purposes, I run this report before the backups take place so that we can see where missing backups might be. So you're seeing these backup data set not found. Well, in large customers, of course, you're going to have potentially hundreds of thousands of backup data sets in play here. So what we have is we have a smaller data set to show where data set backups might be missing. And we use this backup WO report, which is a list of the files where the backup has not taken place. Some of these data sets, for example, with ATM app and DDA app that you see here in the middle, those will be the ones I'm concerned about. FTPs, I'm not actually backing those files up using a different, using DSS or anything. But those would be the kind of things where I could say, you know what, I can streamline this. I can put this into an exit so that we don't actually see those. We only see really the data sets that we're interested in monitoring. In addition to looking for backup data sets that are missing, we also have the ability to look at for duplicate data sets. So in this case here, we can see, if I look at this file.ps, these are data sets that are being backed up by two different applications. If I go down to the inventory down here, you'll actually find that this data set is actually being backed up 4 times in the space of 20 minutes by 4 different applications. So that would be something we'd say, it's obviously being backed up too many times, take one backup there. And we can do that within IZBR with something called CrossApp. And CrossApp will say, you know what, I see this data set's being backed up multiple times. I'm just going to back it up once. And that will reduce the amount of storage space, reduce the number of CPU cycles, but it'll also make recovery easier because, if I'm recovering to a point around this time, well, which one of these 4 backups is the correct one to take? So that would also make it easier from a recovery perspective, because when things are going wrong in your environment, that's when you need to be able to make decisions quickly, not in a timely manner, not in a complicated manner. One of the other features that Butch talked about, I'm going to move on to Timeliner now, that's all the backup and inventory piece. The Timeliner piece is actually looking at data in real time. We kind of looked at it when we saw the ad hoc report earlier, but I'm going to drill down to a particular application again and kind of say, show me everything that's been associated with this particular job name or group of job names. I'm going to go back to one of our demo applications, which is INSCT, and I'm going to look at the jobs that ran within the last 24 hours. I can go back further than that, depending on how much information you have stored. First of all, within Timeliner, and then within job streams where the data is offloaded to. Now from here, I'm going to single out one particular job, which is called INSCT 004. And I can see the various steps that ran. And this is happening, if you were watching this in real time when the jobs were running, you could see actually jobs were active, and immediately when they end, that would also be reflected here in Timeliner. So from here, what we can do is I can then drill down even further, and I can say, oh, okay, so this is the input data set from where this data set came, and here's the output data set that it created. So from here, I can then drill down even further and say, oh, okay, this originally came from an FTP job that came into the system. And then it was subsequently written to by these various steps and then read by step 4, and then by further on by another job in INSCT 005. And that also, that's where the input data set came from. If we look at the output data set, we could say, okay, this is a data set that has been used in multiple subsequent jobs, and then it's also even being used in a completely different application. That's kind of very good if you want to just look at one particular step. But if you want to then go and look at something, what's the big picture about this? We could then say, okay, let's drill down and have a look at all the subsequent jobs where this was done. And we can then see, are there any other follow-on jobs where data sets were created? You can see here, we have some data sets that were used further on in completely different in a completely different way, not even reflecting this current naming convention. Now, that's useful to see what happens after the fact. So I could say, you know what, I don't need to rerun all the jobs. I only need to rerun the jobs which touch a particular affected data set. Now, if I want to go backwards in time, maybe to see how we got to this place, if we've identified that INSCT004 was the problem job, I can go back in time, and then I can see, because we're now going, you know, the time is going backwards, not forwards. We can now see how we got to this place. So from here, I can see, okay, this is where these was fed. It actually came in via an FTP. So it came in, let's say, from off platform here, and this is how this data set was created in the first place. Now, if I have a problem here at this particular point, I can also then go backwards and say, you know what, let me look at the backup table and let me determine where do I want to try and do a recovery from. And I can do that then here, and I'm then presented once again with a restore generator like we saw before. A couple of other things just to quickly mention before we end is that one of the reports also that customers find very useful is the audit check report. Now, this allows me to drill down and see data sets that are being referenced from outside of the application table. And if you recall, the application table is derived from the scheduling system. So this is saying these are, let's say, a form of ad hoc jobs that are being run, but they're not being run through the scheduling system. Now you'll see there's an ad hoc job here, but that's because it's when this particular audit check was run, the ad hoc report application was not defined in the scheduling system. So I can see here, for example, that this user ID, which is me, Chris T, was updating, has updated this data set. So that might be a cause for concern, or it might not be. But those are the kind of things that we can also then run this report and present this, for example, if the auditors want to know more about particular accesses to a data set. Quickly going to touch on another thing that Butch talked about, which is our new support that came in version 1 release 2, which is the ability to recover complete, let's say, ZFS file systems based on their mount points. So we drill down, let's say, from a particular mount point, and it will show us what we have mounted in this particular case. So from here, what I can see is that, for example, I want to do a recovery of this ZFS here, which is actually the base mount point. These are all other mount points that were being created after the fact. So from here, this will drill down into the backup table again, and we'll present again a similar restore panel that we have with DSS. In this case, that's what we're going to be using to do the recovery. So I'm going to call this test 1. I'm going to use a data set name that is similar to this, but I'm just going to call it test 1 as well. And then I'm going to use a mount point ZFS REST 3, because what I'm actually going to be doing is recovering, if all goes according to plan, to a new mount point that doesn't exist in the system, so that we can then look at the data set and then move any files and folders across here. I thought that was going to happen. I think we already have a data set with that name in there, so let me see if I can change that quickly here. If this doesn't work, I'll show you what I created earlier, as it were. But this allows us then to do recoveries to particular mount points, so that we could then we'll use the old cooking show thing. Here's one I prepared earlier. So this would be then the files that are in the system that would then be able to be copied across back into the original file system. So that would be a way of doing the complete recovery. I have a DSS error in there. I'm not quite sure what it was. And in the interest of time, I won't examine that further at this point. But those are the kind of things that we can do here. We track down from the file system level to be able to then track down and do a recovery from that point onwards when things work according to plan. Just quickly, as Butch mentioned, next week we're going to be talking more about the safeguarded copy and cyber resiliency. And we do that using something called our 3D virtual catalog. And from here, this would be kind of like the entry point, just to show you some of the things that we can track with the 3D virtual catalog. And that's going to be here, looking at a particular data set, where it resides now versus where it resided in the past. If you have time next week, I'd be happy if you could join me. It's the same time next Thursday. We will then go into more depth and discuss this 3D virtual catalog and how it is used by the safeguarded copy, surgical recovery piece, and go into more detail on that then. That's all I've got, but thank you very much for your time. I know it's late in the day in the UK, so appreciate you spending time with us today. And I'm going to hand it back to Butch for just some final words.
Thanks, Chris. So really the closing message really is to, from a resiliency standpoint, is really to look at your batch environment, understand your weaknesses that you may have in your resiliency, make sure you have the backups and recovery capabilities. And we hope our solution may be of value to you, but if not, hopefully some of the ideas that we presented will give you some ideas for how to make your batch environment more resilient going forward. And with that, I'll turn it back over to Anna to close out.
And indeed I will. No messages or questions in the chat, so that's going to help us to finish on time. And, okay, just a reminder then that the charity, to donate to the charity, so you get your raffle tickets. The other reminder is to do the feedback for this session, which was 3AR. And remember that one of the questions about the length of the presentation, 9 means it was way too long. You want to be aiming for 5 on that particular question. Every year we get everybody going, no. So we never really know quite what's happening. So please take care with reading the questions. And I think that's everything. Just for me to say thank you to Butch and Chris for doing this session, and to lead the round of applause, and just to say, yeah, please be back for next week's session to follow up. Okay. Thank you.
Thank you. Bye.
Oh, bye. I'll end the session for everybody now. Bye-bye.